Good day again, guys. Today we will be performing another redox reaction experiment where we will be reacting acidified potassium permanganate with hydrogen peroxide. Alright, so you can now notice the color of the potassium permanganate. It is deep purple. The first thing that we're going to do, we are going to acidify the potassium permanganate using dilute sulfuric acid, about 4 drops. 1, 2, 3, 4. So we have 4 drops of diluted sulfuric acid has been added to our potassium permanganate. We're going to swirl it. Alright, so the color is still purple. Alright, still deep purple. So as you know, in redox reaction there are 2 different processes occurring at the same time. We have a reduction taking place and an oxidation. So one of these reagents is the oxidizing agent and one is the reducing agent. So we proceed by adding our hydrogen peroxide at this point in time. Remember, our medium is acidified, so we add. And we observe. Right, so you can actually see without swirling, you see the deep purple color disappearing. Right, you can actually see it for yourself, it's disappearing. The purple color, the reaction is taking place, and you can actually see the gradual disappearance of the purple color. Alright, you can see it for yourself. Alright, you can see that the purple color is gradually disappearing, right? Because a process is taking place. Alright, a reaction is taking place between the hydrogen peroxide and the potassium permanganate. Alright, so you can actually see that the purple color is disappearing. Alright, I'm going to speed up the process a little by swirling it. Right, but you can actually see before I start swirling that the purple color, as just a smaller portion of it is remaining in our reacting flask. Right, so this is what occurs when we do a redox reaction. There's some noticeable change that you will see in while the reaction is taking place. Alright, just remember what we had before. The conical flask had a purple and a deep purple reagent in it, and the deep purple color has now, there's a small portion of the purple color is visible. You can actually see while it disappears. You can actually see there's a small portion, and we did not swirl the mixture at this. So we have not swirled the mixture so far. Alright, so the purple color has disappeared. We call this, we can say that the potassium permanganate has been decolorized. It has lost its color. Right? We also add effervescence or bubbles that was given off when the reaction was taking place between the potassium permanganate and the hydrogen peroxide. In an acidic environment, remember we added the dilute sulfuric acid. Right, so we actually see that the purple color has been decolorized. Alright, and there's no more purple color visible. Now, for this reaction, as you will see, that everything did not occur at once. It took a while for the reaction to reach this stage where the purple color has completely disappeared. So, but we are going to swirl it a little carefully and see if we can even get a clearer color, right, than what we see now. Right, because the process takes a while to occur. As you saw before, the purple color did not disappear at once. It took a while for the redox reaction to be completed. Alright, so we're going to observe it a little bit more and see if there's any more change in the color of a color inside of our reacting flask. Alright, so this is what occurs when you have a redox reaction, there is some amount of visible change that you will see. Either you will see the formation of a gas, or the disappearance of a color, or a new color formed, or something, but there is some visible change that you will see in some way, shape, or form. Alright, so you cannot just see that the color is even becoming clearer as the reaction proceeds. Remember, in redox reaction we have oxidation and reduction taking place at once. So what occurs here is that the potassium permanganate was reduced by the hydrogen peroxide. Alright, but in particular what occurred was that the manganese ion that existed in the reacting mixture was Mn7+. So it was reduced to Mn2+, and the Mn2+ ion, the Mn2+ manganese ion, is colorless, and that is why we're getting this colorless mixture as the reaction proceeds. You can see for yourself, the Mn2+ manganese ion is colorless, so that is why you're getting this colorless mixture now as the reaction reaches its completion. Alright, so as I told you before, it takes a while for the reaction to be completed, but you are seeing it for yourself that the reaction has now basically reached the stage where you have full reduction of the Mn7+ ion to Mn2+ manganese ion. Alright, and that is why we're getting the colorless mixture in our reacting flask. Alright, so hopefully you guys learned again today more about redox reactions and reaction in chemistry all together. Alright, so the oxidizing agent was the potassium permanganate. Potassium permanganate was the oxidizing agent, and the reducing agent was the hydrogen peroxide. Now there are products that were formed in this reaction as well, because remember the hydrogen peroxide was oxidized also in the process. While the hydrogen peroxide reduced the potassium permanganate, the hydrogen peroxide was also oxidized by the potassium permanganate, and in the process of oxidizing the potassium, the hydrogen peroxide, water and oxygen gas was produced also as an end product in this reaction. Okay guys, but you can learn more about that. For today, the basic, the most fundamental thing that I want you to see for yourself is that this is some of the observation that you will get when you try to react an acidified solution of potassium permanganate with hydrogen peroxide. Thank you very much again, guys. Let you guys see again the ending of the experiment. You can see so guys, this is the end of our experiment today. Hopefully you guys learned something about again today about redox reactions and reactions in general in chemistry. Alright, so one of the things that I want you to learn today is that this is one of the reasons why you can use hydrogen peroxide to remove stains, similar to how you guys would use bleach to remove stains. But hydrogen peroxide is a different form of stain remover compared to bleach. Okay, but I just want you guys to see that we can also use hydrogen peroxide also as a bleaching agent. Alright, thank you very much again, and hopefully we continue to learn on this journey. Bye now.